Alright, how to do a second take here. Kind of messed up on the first one, but it's deleted. You'll never know. Ooh, oops, I just said that I made a mistake. Okay, well, we're re-recording and back at it. Okay, so it's a titration. So basically we're taking an acid or a base and dripping it into the opposite here. And we have an indicator in there. Phenolphthalein is a common one. And you can stop when it is the reaction has reached the equivalence point, or that you have neutralized the opposite, an acid or a base, whichever one you started with here, the opposite's up here, and then you can take the volume and figure out, well, what was the number of moles that I needed to, using the volume and this known concentration, we can find the moles, use our stoichiometric ratio and figure out, well, what was the concentration of this stuff in here. And really it's sad that you don't get to do this lab, because there's a cool titration lab that I have that we do where we analyze the active ingredient in aspirin. So it's a shame, but we move on. And here we go. We need the bounce reaction between, there's two parts. There's really like these two pieces go together for part one, and then these two pieces go together for part two, and then this is skipped. So we're using this and this right now. There's your solution, by the way. We're using these two. So we need the balance reaction between hydrochloric acid and sodium hydroxide. So it's HCl plus NaOH yields water. The hydroxide group goes with a hydrogen from this, produces a salt, sodium chloride. +1, -1, you got to make sure your compounds are correct. Then you balance it, so this is +1, -1, or rules of nomenclature hold. This is it, nor ordinary table salt in this case. And then we balance 2 hydrogens, 2 hydrogens, 1 oxygen, 1 oxygen, 1 sodium, check. So it's a 1-1-1-1-1 ratio, which is good. Makes our life a little bit easier. So what do we know from the sodium hydroxide? We have a 0.163 molarity, and over here we have a 0.132 molarity and 10 milliliters, and 10 milliliters is equal to 0.001 liters. So we need that there. So we're going to take this and we are going to do our molarity formula. Molarity is moles over volume in liters. 0.132 equals X over 0.001. You clear it by multiplying both sides by 0.001, and you get 0.00132. All right. Wait a second. Jeez. 1, 2, 3. There's only, sorry, it's 0.01 liters. So this is 0.01 liters, and then that gives us, but that gives us this answer. So it's 0.01 liters. All right, so this is moles of, what is it moles of? Our acid here, so HCl. Now we need to switch compounds. How do we switch compounds? The molar ratio of want over have. Moles of HCl. And our ratio is want, this one, it's a 1. Coefficient of this, it's a 1. So 1 HCl on the bottom cancels here. 1 NaOH. So those of you playing at home, you could even skip that step because it's the same. 0.0132 moles, 2 moles of NaOH. Now all we have to do is use this and this piece here and fill into the molarity formula again. So it's 0.163 equals 0.00132 over X. Okay, please, when you solve this, multiply both sides by X. Okay, this cancels, and then divide the 0.00132 by the 0.163. Okay, and that gives us 0.0081 liters. You could put that in as liters, or you can turn it to milliliters like this one is in. Either way, you're good. Okay? Now, part 2 is these two, as I was saying. It's these two together. So we have a new reaction. which we'll do in purple. How about? Our new reaction is H2SO4, sulfuric acid, plus this here, NaOH again. Guess what it produces? Water. Awesome. And our salt is sodium sulfate. Now wait, I said fix the compounds first. Sodium is a +1. Sulfate is a -2. So you got to have two of these. So it's Na2SO4. Now we got to balance. We need a 2 here. Well, maybe we'll use a different color. 2 here. And we need a 2 here. And we're balanced. Old school stuff, right? So now we take stock of what we have again. Guess what? These two go with this, so it is 10 milliliters again, which is 0.01. Didn't screw it up that time, liters. And it is a molarity of 0.144 m. Over here, we have, once again, the 0.163 molarity. Now it's going to be solved the same way. Fill into your molarity formula. M equals volume in liters. So we're going to fill in, and that's 0.144 equals x over 0.010. That's a liter there. And then we multiply 2, and x is equal to 0.00144 moles of H2SO4. We now have to switch compounds. So we take our 0.00144 moles of H2SO4. We're going to do our stoichiometric ratio. Want over have. What is it? It's we want this, have this, so it's 2 NaOHs for every 1 H2SO4. So there we go. And that doubles this for us, which gives us 0.00288 moles of NaOH. Now we can go back up to here. Okay, this is 6.3 if I recall correctly. And we're going to fill in again. Molarity equals moles over volume. 0.163 equals 0.00288 over V, volume. Please multiply the V over here. Cross it out. And then you got 0.163 V equals 0.00288. Divide, and you get V equal to 0.0177 liters. Awesome. You could put it in liters, you could put it in milliliters. Done. 17.7 milliliters if you like that. All right, awesome.